Okay. And I have shared my whiteboard as well, which I suppose you guys are able to see. Okay. All right. So we started our discussion from P1 mathematics. The first chapter is quadratics. In the first class, we discussed how to solve a quadratic equation through factorization. Then we discussed completing square method. And today we are going to talk about the quadratic formula, right? That is very basic. This formula is also given in the data booklet, but still we need to just look at one example at least in order to cover it properly. So this is 1.3, the quadratic formula. Okay, this is what we need to discuss. Okay, so what exactly is the quadratic formula? Let's start the discussion from that. If you have a quadratic equation, the general form of that quadratic equation looks like ax squared plus bx plus c equals 0. So a is the coefficient of x squared, b is the coefficient of x, and the c is your constant term. Okay, this is a general quadratic equation. Let's see what exactly is the quadratic formula. So if this is your quadratic equation, then x would be equal to, and now I am going to write down the formula which would be given as well, minus b plus minus under the root b squared minus 4ac, and then this thing is divided by 2a. This is the quadratic formula, which is one of the most easiest methods in order to solve any quadratic equation, right? If the examiner would want you to use this quadratic formula, I'll tell you the keywords he would specify, through which you guys would know that you need to use this formula, and you cannot do it by completing square method. You cannot do it by factorization. You need to apply the quadratic formula, and only then you can find the exact answer, right? Or it would be basically a short approach. You just need to plug in the values and then use your calculators. Okay, let's quickly talk about an example. This topic is very, very easy. Let's talk about an example on the other side of the page. Okay, so let's say, for example, the question would be something of this type: solve the equation 6x squared minus 3x minus 2 equals 0. This is your quadratic equation, and the examiner would tell you, write your answers correct to 3 significant figures. When he will talk about the number of significant figures or decimal places, that is how you know that your answer would have a decimal in it, right? And that is a direct hint that you can directly just use this quadratic formula, because every time when we look at a question, we first of all think about it to solve it by factorization and then other methods. But if the examiner is telling you give your answer correct to these many significant figures or these many decimal places, it means quadratic formula would be used. Okay, let's apply the quadratic formula quickly. So the solution would be x would be equal to, what is b? B is the coefficient of x, so minus 3 is b. So I have minus in the formula, then I will plug in the value for b, that is minus 3. Then we have plus minus under the root b squared, again minus 3 squared minus 4. A is the coefficient of x squared, 6. And then this is the constant term, that is minus 2. And this thing is divided by 2a. So this exactly is your quadratic formula. Now you can see that this is going to give you two answers. One answer would be when you will add this thing, and the other answer would be when you will subtract this thing, right? Please, all of you, Use your calculators and tell me the exact answer. Make sure that when you're plugging in values, just be careful about the BODMAS rules and then tell me the answer. This minus into minus would become plus. Then let's find it out with plus first. 9 minus into minus would become plus. 4 into 6 is 24, into 2 is 42, divided by minus 4. And the other one would be 3 minus root 9 plus 42 divided by minus 4. One second. Yes. Yes, please do your workings and then tell me the answer. This is 48. Okay. I'm just writing down the answer for my reference. Okay. I'll wait for a minute, please. Yes.
I want to ask if A is 6, then why did you write 2 into minus 2?
Yes. All right. Okay. I'm sorry about it. That is actually correct. I'm really sorry. This is going to be 6. That is true. Really sorry about it. Once again, this is 2 multiplied by 6. And then this is again 2 multiplied by 6. Yes. But this answer is correct. This answer is correct, right? Yes, thank you very much for telling me. I'm sorry about it. All of us know that A is the coefficient of x squared, B is the coefficient of x, and C is the constant term, right? Okay, please tell me, are you guys getting the same answer, 0.879 and minus 0.379? Please confirm this.
Yes.
Okay, thank you. All right. Okay, all right, great. Okay, so this was a simple topic. It's just a way of solving a quadratic equation for students who have just joined. We are on the first chapter of P1 maths, that is quadratics. This is the third unit, quadratic formula, and it's just the use of quadratic formula, right? Okay, all right, let's talk about one of the most important contents or units of this chapter. I am going to clear the screen. Okay. Okay, this is basically solving a simultaneous equation. Now here, one of the two equations would be linear and the other one would be quadratic. And this time around, we will be solving this combination of simultaneous equations. So let's talk about that. Okay. This is the fourth unit of this chapter. 1.4. And we will be solving simultaneous equations. Okay, let's discuss this through an example. It is 2x plus 2y equals 7. And then it is x squared minus 4y squared equals 8. Okay, these are the two equations and we need to solve this. All right, okay. So students, we know how to solve simultaneous equations. We have been discussing two methods in O levels. One is elimination, the other one is substitution. But how do we solve it? Let's talk about it. This time around, the combination is a bit different. We have one linear and then we have one quadratic. How do we solve it? Let's look into it. So the method is very easy. Again, we will be using substitution here. All right, so let's use equation 1 and let's make x the subject. So it is going to become 2x equals 7 minus 2y, and this would give me x equals 7 minus 2y divided by 2. This is the value of x which I am going to substitute here, and this would give me a quadratic equation in y only, right? And then we know how to solve any quadratic equation. So let's plug in this value over here. X is 7 minus 2y divided by 2, so squared, minus 4y squared equals 8. This is equation 2 after plugging in the value of x. Okay, if you have any questions, any doubts, just ask me directly. I'll be using a better color from now on just so it's more visible. Let me just make lines. All right. So let's just start expanding it. The numerator would become 7 squared. It would be 49 minus 2ab. So it would become minus 28y plus 4y squared. If anyone has any difficulties in this expansion, you need to tell me, okay? Minus 4y squared equals 8. And then I am going to just take LCM over here, and it would now become 49 minus 28y plus 4y squared. The total, the LCM would be 4. Now I have 1 here, so I need to multiply it by 4. It would become minus 16y squared equals 8. And I am going to take this 4 to the other side, and then it would become 49 minus 28y plus 4y squared minus 16 y squared equals 32. And finally, I am going to simplify the entire equation. 12 squared plus 28y minus 17 equals 0. Okay, so this is what you need to do. This would be our quadratic equation. Those who were not able to understand anything, forget about everything. Just focus on this part, okay? Those who have just joined, you guys are coming from the O-level backgrounds, okay?
Shouldn't that number be negative?
Sorry?
Shouldn't this be negative?
No, it is positive. I've just changed the entire signs basically, right?
Okay, sorry.
Yeah, so I've simplified it in a way that I multiplied negative, and the final version would be this. Okay, you guys can take your time and see if you are getting this equation from this one. It is correct. Okay, just check that and then solve this quadratic equation whatever way you're comfortable. You can use the quadratic formula, you can do it by factorization, whatever way you're comfortable. Please try doing it. I'll give you 2 minutes and then tell me your answers. And if you were not able to understand the background stuff, forget about it. Just solve this quadratic equation in the red box. That is it. Yes, 1 more minute and then please just type your answers. It's completely fine if your answers are wrong. I would not even mention your name. I just want you guys to practice with me, okay? Just so we know if you're able to understand anything or not. Yes, is anybody done? Do we have any value of phi? Just message me directly. Okay, I got one answer. Let me check. Yes, very well done, Saad. Excellent. And what about the other students? Okay, very good, Munja. Good job. Well done, Rafi. Excellent. Okay. All right, let's try solving it. So when you will think about it directly, when you will think about the, let's say the quadratic formula, things look apparently difficult, but it would certainly give you the answer, right? If you start factorizing it, you know this equation cannot be simplified further. You do not have any number coming common in 12, 28, and 17, so you cannot take anything common. So directly, if you multiply 12 with 17, this is 204. So you need two numbers such that when you multiply them, you get 204. And when you add them or subtract them, you get positive 28y. So this could be a bit challenging because it would be done through hidden trial method, but still we will try a few factors of 204. And finally, after those attempts, we are going to get 204 divided by 34 gives you 6, right? So when you will multiply 34 and 6, it would give you 204, right? But we need minus, so we can just add minus over here. Let's try this one. So it is going to give me 12y squared plus 34y minus 6y minus 17 equals 0. And then I can just take things common. It is going to become, okay, now what can I take common from here? 2y. So it would become 6y plus 17. And then I can take minus 1 common. So it would give me 6y plus 17 equals 0. My two factors would be 2y minus 1 into 6y plus 17 equals 0. So y is equal to 1 by 2 and y is equal to minus 17 by 6. Okay, these are going to be my two roots of y. Okay, this was one method. I did this by factorization. We have just discussed the quadratic formula. You can directly plug in the values of a, b, c. This would be your a, this would be your b, and this would be your c. And after plugging in the values, you would get the same answer. Okay, so you got the values of y. When you will be solving a simultaneous equation, at this point we have two variables. This is the first variable, this is the second variable. So solving a simultaneous equation means I need to have both the values of the variable x and the variable y. Okay, we are done with y. Now I would want all of you to find the values of x. This was the equation. I know that x is equal to 7 minus 2y by 2. So the first value of x is going to be 7 minus 2 into, I'll plug in the first value of y divided by 2. Okay, this is going to give you x equals 3. Very good, excellent. And when you will plug in y equals minus 17 by x, please tell me what value of x are you getting. This is a practice for you. Just plug in the value of y quickly. This is very easy, all of you can do that. Yes, please try doing it quickly and then tell me your answers. It is 7 minus 2 into y is minus 17 by 6 divided by 2. We are going to simplify this, and this is going to give you 19 by 3. 19 by 3 is going to be the answer. Yes, any confusions? Anyone please tell me if you are good with this or not. I'll wait for all the students. And then I am going to talk about the next topic. This is important. Are we good with this?
Yes, miss.
Yes.
Ma'am, so,
Yes.
sorry, on 7 minus 2y squared over 2, you got 28 minus 49 minus 28. So I didn't see how did you get 28 here?
Sorry, just tell me once again, which point exactly are you talking about?
The 1, 2, 3, the third step, then we went on the fourth step where it says 49 minus 28y plus 4y squared over 4.
Okay. One second. One second. This one or this one?
On the left, on the extreme left.
Okay. This one?
Yes, ma'am.
Okay. All right. Okay. So it's completely fine. Okay. This is what we had. Are you good with this one?
Yeah, I'm okay.
Okay. I plugged in the value of x and this is what I got. Okay. So this is a fraction and I have a square on this fraction. This means I will be squaring the numerator and I will be squaring the denominator. So I can write it as, I am going to write it down here directly. This thing would be squared and then this thing would be squared. The square of 2 is 4. That is good. And what about the square of numerator? So think about it as a minus b squared. Okay. We have a squared. Then we have, I'll write it down on top of it.
Okay. Oh, sorry, I'm with you now.
No, it's completely fine. A squared minus 2ab. And then we have plus b squared. And then this minus 4y squared is coming here, right?
Okay.
Okay, all right. So this was a good question, obviously, because at times we get confused with such things as well. It's completely fine. No, it's completely fine. And then after simplifying, we got this red quadratic equation, and then I've just used factorization. You can use quadratic formula as well. And then finally, we got the value of y as 1 by 2 and minus 17 by 6. And after plugging in the value of y over here, I got two values of x. One was x equals 3 and the other one was 19 by 3, right?
Yeah.
Okay, great. And are we good? All of you, please confirm.
Yes.
Yes.
Okay, all right, great. Okay, thank you. I am used to asking this again and again because for some reason I feel like at times students are not letting me know and then, it is not good for them. Okay, I'll clear the screen. Let's talk about the fifth section of this chapter, that is solving more complex quadratic equations. Now, when it says more complex quadratic equations, I'll write down an example and then you would understand the idea of this section. This is 1.5. It says solving more complex quadratic equations. This is what we have. Okay. Right, so let's talk about an example, what exactly a complex quadratic equation looks like, and then we'll see how to deal with it. Let's talk about example number 1. It says 4x to the power 4 minus 37 x to the power 2 plus 9 equals 0. Now we know an equation with x is said to be a linear equation, right? If the highest power of x is 1, for example, 2x plus y equals 1 is a linear equation. 2x equals 2 is a linear equation. 3x plus 1 equals 5 is a linear equation because the highest power of the variable here is 1. Okay. if we talk about quadratic equations, we know that the highest power of the variable is 2. But this time around, the highest power of the variable has changed to 4, and still they are saying that it is some sort of a complex quadratic equation. Why? Because I can solve this equation by converting it into a quadratic equation, and yeah, that is the idea. So let's get started. Okay, so what I can do is I can say, I can make a variable y, and I can say that y is equal to x squared. Okay, I can say that y is equal to x squared, and now I am going to plug in y. 4, the coefficient of 4 would be now y squared minus 37 y plus 9 equals 0. Now what's the difference? The difference is that this equation with degree 4 has been converted to this quadratic equation. I can find the values of y, and once I have the values of y, I can just plug in y here and I can find the values of x. So that is the idea. We can solve different equations with different degrees by converting them into a quadratic equation. Okay, let's solve this quickly. Now, please solve this equation. It's very easy. You can directly factorize it. Tell me your answers. I'll wait for a minute and then I'll solve it as well. Okay, let's do it together. So I know 4 into 9 would give me 36 y squared. I need two numbers such that I multiply them, I get 36 y squared. When I add or subtract them, I get 37 y. Okay, so I got one answer, and that answer is correct. Very well done, Saad. Excellent. Okay, very good job. Okay, 36y squared is what I would get by multiplying 4y squared and 9. So the two factors could be 36 and 1. Okay, how? Let's see. 4y squared minus 36y minus y plus 9 is equal to 0. Now I can take 4y common. It would give me 4. It would give me y minus 9. Then I can take minus 1 common, and it would give me y minus 9 equals 0. And the two factors would be 4y minus 1 into y minus 9 equals 0. Okay, I am going to erase this now because we are done with this. Okay, then once we are done with the factorization, the final answer would be 4y minus 1 is equal to 0, or y minus 9 is equal to 0. And this would give me y equals 1 by 4 or y equals 9. So these are the two values which I am going to get for y. Okay, so now I got values for y, and again the question was in x, so I need to plug in the values back in y and then find the final answer. Okay, one thing is clear: in a linear equation, the maximum number of solutions used to be 1. In a quadratic equation, we are getting 2 answers. So if the degree of your equation is 4, you must get 4 answers, right? So obviously this is not complete yet. We need to add a few things more. I know that y is equal to x squared. So I can make x the subject. It would become x equals under the root plus minus under the root y. Okay, so let's see. This would mean that x is equal to under the root 1 by 4 and x would be equal to plus minus root 9. So this would give me plus minus 1 by 2, and this would give me plus minus 3. So these are going to be the 4 values of x. I'll repeat it one last time. It's important. This is the 5th section of the first chapter, that is quadratic equations. Here we will be talking about some different equations, some complicated equations which we don't know exactly how to solve. But once we have converted that equation into a quadratic equation, we would know how to solve it, right? So this is your equation with degree 4. After using this substitution, I got this quadratic equation, right? We have just solved this quadratic equation by factorization, and I got y equals 1 by 4 and y equals 9. But the question was about solving this equation, not this equation. Okay, so in order to solve that equation, again I need to use this thing. I made x the subject and it would give me plus minus root y. I've plugged in the values of y over here and then over here, and it gave me plus minus 1 by 2 and plus minus 3. So the four answers are plus 1 by 2, minus 1 by 2, plus 3 and minus 3. Okay, we would get four roots for an equation with degree 4. Any confusions, any difficulties, please tell me quickly if you're good with it or not. Yes, I am going to wait. Please tell me, students, are we good with this one?
Yes,
Ma'am,
Yes.
how would we say that y is equal to x square?
Acha, okay, I'll tell you. That's a good question. Okay. Now, since here we need to convert this equation with degree 4 to a quadratic equation, I could see that I have x squared here and I have x to the power 4 here. What is happening in a quadratic equation? For example, let's say if my variable is b here, I would be having square of it, right? This made me think that if I will use a substitution of this type, then I would be able to convert this equation with degree 4 to a quadratic equation. And I know how to solve a quadratic equation, right? That is why I've used this substitution. This is just a random substitution. You could have used b equals x squared, any other variable, but in order to convert this equation to a quadratic equation, we have used this. Okay.
Okay.
Are you sure that this has answered your question?
Yes.
Okay, all right, great then. Okay. So next example is for you. You need to solve it. I am going to clear the screen, and for all of you, not for one student, obviously, I am going to write down the question. This practice is extremely important for you guys. Question number 2 of this section is x minus 4 root x minus 12 equals 0. Again, students, the idea is same. You need to convert this to a quadratic equation by using a suitable substitution. Last time we used y equals x squared. It's not necessary that we will be using the same substitution again, right? We need to use something different. So I'll give you 2 minutes. It's very easy. Solve it and then I will solve this question. Yes, once you're done, just you can let me know. You can just type your answers in the chat box. or directly to still be the answers? One more minute, students, and then I will solve this question. Please try doing this. Do not waste this time in waiting for me or anyone else.
6 and minus 2.
Excellent. Very well done. Very good. All right. Okay. Let's solve this question. Okay. Now it is x minus 4 root x minus 12 equals 0. You guys only know how to solve a linear equation. You know how to solve a quadratic equation. We don't know how to solve this different kind of equation. Now, this is not a linear equation. This is not a quadratic equation. This is a complex equation which we need to solve, right? It's a complicated equation. How to solve it? Okay. I can notice one thing, and that one thing is that the square of this number is right here, right? That is what I need to notice every time. So what I can do is I can just say that y is equal to root x. If y is equal to root x, x would be equal to y squared. Obviously, when I will square both sides of this equation, it would give me y squared equals x. Okay, so I have used this. So let's just plug in the values. X is equal to y squared. So this complicated equation would be converted to y squared minus 4y minus 12 equals 0. This is going to be the equivalent quadratic equation. Okay, now I need to factorize, so I will just factorize it quickly. The factors would be y minus 6 and y plus 2 equals 0, and this would give you y equals 6 and y equals minus 2. Now the question was not about y. The question was about x. Always remember, if the examiner is telling you to solve this equation, he wants you to find the values of this x, not y. Okay, so now we are going to use our substitution again. We know that y is equal to root x. This means that x would be equal to y squared. Yes. This is what we had. Okay, so this would give me x equals, I am going to square this number right here. It would be 6 squared, and we are going to have 36 here. This is going to be the answer. Okay. All right. So I am going to just repeat this one last time. I'll tell you we did not consider the solution because obviously it's a negative solution and we cannot have a negative number for under root, right? Okay. I'll tell you. So the idea is that this is what I had in the beginning, the question statement, right? I could see that this variable and this variable, they have a link. The square of this variable was giving me this. Okay. So that made me use this substitution. I used y equals root x, and when I will square both sides, it would give me x equals y squared. Okay, now I got y squared minus 4y minus 12 equals 0. I've used factorization and it gave me y equals 6 and y equals minus 2. Okay, now what is happening here? When I'm saying y is equal to 6 and y is equal to minus 2, it means that 6 equals root x, and then we have minus 2 equals root x, right? These are the two things we have. We need to find the value of x, so I need to square both sides. I will square this side and this side. This and this would be cancelled and I would get 36 equals x, right? This is what I'm going to get. And this solution would not be considered, right? We are not going to consider this solution. We are only going to consider this solution because of this minus sign right here. Is it okay?
Yes, ma'am.
And what about the other students? Please confirm this. This example was a bit different. Are we good with this one? This is the last thing for today. Just feel free to ask me if you have any questions.
Miss, I have a question.
Yes.
Miss, I took the x is equal, let the x is equal to y square. So it's like eventually when I'll be adding the same substitution here, wait a second, at this place. Is at this place, for example, always pen. X is equal to y square. So miss, I can also consider this value and make it positive like this. That is equal to 4.
Yes. Okay. You can think about it this way. You can think about it this way. But you have y equals 4, right? Finally, you're getting 4. Okay, so when you will plug in the value in the original question, this would be satisfied. 4 minus 6. Yeah, that is going to be the issue. I'll tell you. This would be the issue. Just plug in 4 here and you would not get a 0. You would get minus 24, right? This is something which I don't want to talk about for now, but I'll tell you. Do you guys remember in O-levels that whenever we used to solve a quadratic equation, we get 2 answers. And a better practice is whatever answers you're getting for x, just plug in those values back in the equation and see if your equation is being satisfied or not. Because technically, I'll tell you, technically in quadratic equations, this can be an issue, but not, like it is an issue, I would say 20% or not more than that, right? This time around, this is not a quadratic equation, right? The degree of this equation is 1. It is not a quadratic equation. This is a different equation. So technically you won't be getting 2 values for this. Okay. So that is why I did not want to talk about it. But now since I have a question, let's just discuss this as well. Whenever you would be getting 2 answers for any equation, just plug in the 2 answers back in the equation. For example, I got 36 and I got x equals 4. Okay, just plug in x equals 36 and check if you're getting 0. Plug in x equals 4 and check if you're getting 0. If you will plug in x equals 4, you are not going to get 0. You would get minus 24 or something else, right? So that is how I know that this would not be considered. We are not going to consider this, although this is correct. But when I will plug in the values that I'm getting from this solution, my solution would be invalid. It won't be satisfied. That is why it is not the answer, right?
Yeah, I used the different methods now.
Sorry, yes, say it again.
I was saying I used a different method, but I got the same answer.
Okay, that's great. It's you use some different substitution, right?
Yeah, I took x to, minus 4x, then I say 12 minus x, then I squared the y squared square root of x, and 12 minus x squared, then I found the quadratic equation from there. I tend to, yeah, when you substitute 4, it will give you 16 is equal to 0, which is not the solution.
Okay, what x you used? Y equals what for the substitution? I could not understand that part.
Oh, I said minus 4 square root of x, and I squared that one to get rid of the square roots, and it gives me 16x, which is got to be 100. Then I took x to the other side and 12 to the other side, and it becomes 12 minus x plus 12. Then I squared that one as well, which would give me 144 minus 24x plus x squared.
All right, I get your idea. So basically you have used different substitution, but you made sure that it is balanced, right? That is good. But you know, direct approach is more better, right? I'll tell you. Just the some students get confused during the substitution because they want a fixed method. The fixed method is if you square this number and if you're getting this variable, if you square this and if you're getting this, just use this, just use y equals this, that is it. Okay, this although you would get a correct answer from that as well, but you know, not necessarily, right? You would have to do some additional steps in order to balance that equation, because initially the equation would not be balanced, right? So you'll have to use a different value for x then, so it would be more difficult, right? The good idea is if you are squaring this number and after squaring you're getting this variable, just go with this one, just square it, and you would know that yes, then it would become a quadratic equation, and that is good, right? So this could be a direct method which all the students can use. And also you guys can use this method to see if this is if this or if any equation can be converted to a quadratic equation or not, right?
Yours is very simple, man. I use it.
Yeah, so
I think the method is very simple.
Yeah,
it's
so
nicer.
all of us can use this. Okay, very good. Okay, so I hope we are good with this. I will stop sharing the screen. I will stop the recording.